Okay, like I said, I'm just going to do a quick recap on 1.5, 1.6, and 3.1, which you were supposed to cover on Thursday, which the sub told me you guys were able to cover. So 1.5, 1.6 was dealing with absolute value inequalities. So just remember the notation here of a parentheses versus a bracket. Parentheses means the endpoints are not included, and brackets means that the endpoints are included. Okay, so that's in the interval notation. In regards to inequalities, you have the alligator signs, less than, equal to, greater than, equal to, right? So no difference between the two and how you would write your answer. When it says something to graph, okay, a lot of times students try to do like a linear, like a positive slope, negative slope. When we're talking about uh, interval notation inequalities, these types, the graphs look like these, right? So either you have something in between, or the arrow is going to the right, or the arrow is going to the left. One thing I always tell students is that if you look at, say, the second one here, it says x is greater than or equal to 1. Notice that the arrow corresponds with the inequality. So the arrow is pointing to the right, the inequality is also pointing to the right. Here in the bottom, the arrow is going to the left, and then the inequality is also going to the left. All right. So, but that only works when the variable is on the left side. Okay. Um, Then you went through several examples of solving inequalities. I tell students to solve them like as they're solving a regular equation. Okay. So the big part about solving inequalities is that if you are dividing or multiplying by a negative number, then the inequality flips. So in this case, on the right side here, it was less than. So when we divide by negative, it flipped to a um, sorry, yeah, it flipped to a greater than. Okay. So again, when you're dividing or multiplying by negative, you have to flip the inequality. Okay. Also, again, another thing here when you're solving, if you have a negative out here, you need to distribute that. Both those two terms are going to change. So it was a positive 2, negative 4 times 2 is a negative 8 now. It was a negative x. Negative 4 times negative x becomes a positive 4x. Okay. And again, make sure you know how to solve the inequality, write it in interval notation, and know how to graph it. Okay. So um, this one, students miss this question a lot. So when you're solving an equality has three terms like this, you solve in the middle. Okay. So you subtract all, like for example, this is 4 is less than 2x plus 2 less than equals 10. They make this more complicated than it is. You just isolate the x by itself. So you subtract 2 in all terms. Okay. Then you divide by 2. Okay. If you divide by negative, then just flip the inequality. But again, this question here is missed a lot because students are making it more complicated than it needs to be. Okay. All right, so that's solving inequality. The other part was now you're introducing absolute value. So absolute value is the graph looks like this as a V shape, okay? And so if you take a absolute value of any number, it becomes positive, right? So absolute value of 3 is a positive 3. Absolute value of negative 3 becomes a positive 3. And what that's saying is that it's how far is it the from 0. So it's 3 units from the right and then 3 units from the left. That's why you're getting two answers there. Okay. So, or the absolute value of any number becomes that positive. Okay. But anyway, the absolute value, the equation or the graph looks like a V shape. So remember that. So what ends up happening is that any numbers that you put in on the left side, as you look at this one here, becomes positive. So the absolute value of negative 4 is positive 4. The absolute value of negative 2 becomes positive 2. And so that's what ends up happening. The y values, even though they were negative originally, when you put it in the absolute value, it becomes positive. Okay. All right. Now, the one thing about absolute value, which I cannot emphasize enough, is that again, students make it more complicated than it needs to be, is you need to get the absolute value by itself in order to apply the theorem. Okay. All right. So again, in order to apply the theorem, you have to get the absolute value by itself. So like this problem here on the right, we got the absolute value by itself. So so we got 1 minus 2z equals 1. Now it's by itself now, so I can apply the theorem, and then I would apply theorem 1 here, where you have a positive 1 and a negative 1. Okay. All right. So in regards to these types, A has to be positive in order to apply the theorem, right? For rule number 1 or theorem number 1. Okay. All right. So again, I cannot emphasize it enough. Please get the absolute value by itself first in order before you can apply the theorem. Okay. All right. So same thing here, what I did on the left side, I got the absolute value first, and then you'll have two separate equations. All right. So, all right. One thing I also want to emphasize, like this problem gets missed a lot, and I would mark this down if I were you. So if you have the absolute value of say 2 minus v equals -1, students will try to solve this. But again, the rule is A has to be positive. So it's not possible that the absolute value 2 minus v is equal to -1. That's never possible because again, whatever you put in absolute value is a positive. It spits out a positive. So in this case, this is not possible. But this question is missed a lot. Even though I mentioned it, students still miss it. Okay? So mark this down if I were you. Okay, and then you started solving things with the less than and greater than. One thing I do tell the students to help them remember um, when you're solving less than, greater than, is a play on words. So if it's less than, right? I know this is not how you spell than, but less than. So if it's less than, that means you'll have one equation, okay? So this one was the absolute value of 3x is less than 15. And then you got x by itself, all right? So it's going to be that 3x is going to be between -15 and +15. So less than means um, you have this less than symbol and it's only one equation. If it was greater, okay, then you're going to have two separate equations, all right? One is going to be going the left, so less than -6 in this case, and then going to the right, greater than 6 in this case, right? So greater, you have that or in the middle. You have two separate equations. So again, just real quick, less than means you have one equation. Greater means you'll have two separate equations. That's how I always remember it. Okay. Again, these problems here, I'm just telling you right now, are missed a lot on the test. Okay. So they just literally leave it blank sometimes. All right. Any questions on that? Again, like I said, I was just doing a real recap on that. Okay. All right. And then the next thing you guys covered was section 3.1, which deals with functions. Now, there are two parts to section 3.1. Um, so the most important part about section 3.1 was just some of the highlights here is I'll write it down here. Is again, this is dealing with functions. Okay. So number one is what is a function, right? What the world is a function. So the proper definition of a function is that for every x, there can only be one y value. For every x, there can only be one y value. Okay. And how you determine that is by doing a test, right? Which is the vertical line test. All right. So the vertical line test, I call that VLT. Okay. So again, if you have a parabola and you're able to draw a vertical line, it will only cross at one time. So this is a function. However, if that parabola is, going this other direction here, if you draw a vertical line, it's going to cross it twice. So that means this is not a function. Okay, so remember that. And again, this part here is miss a lot. All right. Also, another thing about function is that if the x repeats, okay, then it is not a function. Okay, so for example here, let's say that, I don't know. So I'll draw a graph here. Okay, let me do a different color. So, all right. So let's say that this point right here is, I don't know, 3, 3, 2. Okay, and then this point down here is 3, -2. Okay. All right. So notice that the x, this is our x value. That's our x value. So notice that the x value repeats. That's what it's saying. Okay. That's what it's saying. If the x value repeats, then it's not a function. All right. The other component of this section was dealing with domain. Okay. So, which is huge. Right. So the other part of this is dealing with the domain. Right. So remember the domain is dealing with the x values. And then the range is dealing with the y values. Okay, but I want to focus on the domain. All right, so if you have a parabola, right, remember the parabola looks like this. So in this case, the domain here, right, is going to be all real numbers, right? All real numbers, or you can represent it as a capital R. All right, because you could put any number in there, it's going to work. All right, any number in there, it's going to work. All right. What gets tricky is when you have rational equations or rational functions. All right. So if I have y is equal to 1 over x, this is a rational function. Okay. Rational just means you can write it as a fraction. All right. So this graph looks like this. Right? So notice that every single one works, right? There's a value for every single one, except where? 0, right? 0 doesn't work because we can't divide by 0. Okay? So in this case here, the domain is all real numbers, right? Except at x equals 0. Remember that. Okay? At x equals 0, we can't do it. So if we had another one, say, I don't know, say we had x squared minus 4. To find the domain, we just set the denominator equal to 0 and we solve. So then in this case, we get x squared equals 4. Let's take the square root on both sides. We get plus or minus 2. So what this means is that the domain is all numbers except at here. It can't be plus or minus 2. Because again, if you plug in plus or minus 2 in here, it's going to make the denominator 0. So what I'm saying is if you have a rational function, you take the denominator and you equal it to zero to figure out which number is not going to work. That's the purpose. That's what I'm saying. The other part of the domain here that I want to focus on are the radical equations or radical functions. Okay, so a radical, right, looks like y equals square root of x. Square root of x, we're talking about real numbers. I can put any number in here. I can put any number in there except what? And I can't put except negative numbers, right? I can't put negative numbers in there. Okay? I can't put negative numbers. If you put in a calculator, it's not going to work. Because again, we got to look at the graph, right? If the graph of square root of x looks like this, okay, if you understand the graph, then the math makes sense. Right? The graph looks like this. This is y equals square root of x. So notice that on this side here, there's nothing. There's nothing there. So the calculator can't calculate because there's nothing to calculate. The graph doesn't exist here. Okay, so it only exists when it's greater than 0. So in this case, when you see a radical, okay, it's going to be you get whatever is inside that radical and you set it to greater than or equal to 0, because those are the numbers that are going to work. So for example, if I have y is equal to square root of, I don't know, x minus 4, okay? What's going to be the domain of this? Well, I just take the inside of that radical and I set it to greater than or equal to 0, and I solve. So in this case, the domain is going to be anything bigger or equal to 4. Because if I pick any number less than 4, okay, it's not going to work. So if I put 3 in there, that's going to be 3 minus 4, which is negative. So I can't take the square root of a negative number in the real world. All right. All right, and then the last part here in this section that hopefully you talked about was um, the sum, difference, product, and quotient. So if you had f of x plus, sorry, f of plus g of x, and again, I'm talking about this because, again, this problem is missed a lot. F minus g of x, and then f times g of x. And then f over g of x. Okay. So this up here, this is the sum. So this is sum. This is sum here. This is the difference. Okay. This is multiplication or product. And this is division, or they call it quotient. Okay. So what happens is this here and this here are the same. It's saying you can write it as f plus g of x, or I can write it as f of x plus g of x. They mean exactly the same thing. It doesn't mean I'm trying to solve anything here. Okay, that's what students try to do. It's saying this notation is the same thing as this. Just like, you know, f of x, I can write it as y. They're the same thing. Okay, f of x and y are equal. They're the same thing. I can write it as f of x, or I can write it as y, right? I don't write them both. I just choose one of them. Okay, so that's what it's saying. So if you have something like, um, if f of x was equal to 2x plus 1, and g of x is equal to 3x minus 2, then I can just put it in here, right? So this would be f of x, 2x plus 1 plus 3x minus 2. Then I solve, okay? So that becomes what? 5x minus 1. Okay, so this one here becomes 5x minus 1, right? So I just simplify it. That's all I'm doing. This one I add them, this one I subtract. So I got 2x plus 1 minus 3x minus 2. Okay. All right. And this part here is missed a lot because students forget to distribute that negative to both terms. So this becomes 2x plus 1 minus 3x plus 2, which is negative x plus 3. Okay. So that would be the answer. But again, the students miss this a lot because they forget to put the negative to both terms and they only put it the first term. This one here is you multiply. So you get 2x plus 1, 3x minus 2. Okay. So when you do that, you just get 6x squared minus x minus 2. And that's all you do there. That would be the answer for that. And then this one here, it means you divide. So you take 2x plus 1 and then divide it by 3x minus 2. Okay. All right. Now, if they're asked you to, again, here, there's nothing else I can do that's simplified already on the bottom there. So that will be the answer. Now, if they did ask you about what the domain is, just think about what the graph looks like. So 5x minus 1, that's just a linear graph. That means the domain here is all real numbers. Okay. This one is negative 3x plus 2. Again, that's also linear, but it's a negative slope because you have a negative here. So that, again, that's all real numbers. All right. This one is a parabola, so it looks like this, right? So that means all real numbers. This is a rational function. This one at the bottom here, so that means you take the denominator, set it equal to 0, and you solve for x. So x is equal to 2/3. So that means the domain here is all real numbers, except x cannot equal 2/3. So all real numbers except x cannot equal 2/3. Right, those basically the cliff notes of that lecture, right? And I do want to point out one more thing, and that is um, so if I have a graph, right, and it does something like oh, okay. So if I have a graph, right, and so say the graph, I don't know, uh, does something like this, right? Let's say this is a parabola, going like that. Okay. So in this case here, is this a function? And the answer would be no, right? This would not be a function because it doesn't pass. It does not pass the vertical line test, right? Because if I draw a vertical line, it crosses it twice. Okay. So it doesn't pass the vertical line test. So it's not a function. All right. The next part it's going to ask you is what's the domain of this? Remember the domain are your x values, right? So in this case, the domain will start at 0 and it goes to infinity. Okay, so that would be the domain here. So I would write it as 0 to infinity. Okay, and then the range here, well, the range, this is going to keep going all the way to the negative side and all the way to the positive side, right? So it doesn't matter. So in this case, the range for here will be all real numbers. Okay, because it goes infinitely to the negative directions and infinitely to the positive direction.